Ready? Okay. So, the next question, question 8, is this. We have the equation of the plane, and we have a line with vector equation. From what we have done under vectors, this is called what for the vector, for the line?
The direction.
The direction. Right? This is the directional vector of that line. And from this, you already know, from your RA equals RA equals, okay, I'll show you this first. Everything you need is in your formula booklet. Vector should be chapter 3. Here. It's right here. From here. This is the normal, isn't it? This is the normal. This is what? Anyone? What does your R represent? Any arbitrary point. Your XYZ. And what does your A represent? A known point. Like a 1, 2, 3. Just like when you're discussing the equation of a line. How do we get the equation of a line? If the center is A, B, which is a known center, you're trying to determine the locus of a point that is always the same distance from this point. So regardless of where you look at. So that point is an arbitrary point. It could be anywhere with radius r. So from the distance formula, r squared is equal to x minus a squared plus y minus b squared. When you further expand this, because r also is known, a and b are known, x is the arbitrary point, a is the fixed point. Similar thing here. Okay? So once you are able to see that, from here, using that Rn equals an, this is your xyz. This is the normal. So the normal in this case is 2, 1, 2. That is why you have 2x plus y and 2z. For the NA, this is a known point, multiplying the 2, 1, 2, 1, 2. And that's what led to this 3. So if you have a plane, as we discussed, if you have a plane, the normal to your plane is this vector, 2, 1, 2. And you have a line whose directional vector, the directional vector of this line is this. The question is talking about, I'm going to draw that very clearly. So we did something like this. You have a plane. The normal to this plane is n. Now there is a line. The line this, the acute angle between the line and the plane. So the line comes from somewhere like this. So the acute angle, so this will be like a perpendicular. Can you visualize that? This angle is what? 30 degrees. Which means the angle between the line and the normal to the vector is 60 degrees. Right? You have already done angle between two vectors. If you don't remember, go to your formula booklet. No need to memorize. Angle between two vectors. Cos of the angle, the dot product of the two vectors, Absolute, of course, absolute value, because we are trying to avoid negative. That is why you have the formula cos of the angle between the two vectors, where theta is this, not this, is equal to the dot product of the two vectors, maybe u and v, but in this case they are not u and v. The normal, okay? What notation do we use for the direction of a vector? Vector direction. What?
B. Norm is B.
We always use just b. Yeah. So we have r is equal to what? Vector equation of a line. What is it? Oh yeah, it's here. So from this, r is equal to a plus lambda b. This b is that direction we're talking about. So you can use b or you can use anything. It doesn't matter. Okay? So maybe something like this. Then their individual absolute value. So this is not like dot product. This is just normal multiplication of numbers. Okay? So try to give yourself a sketch as well. That will remind you whatever you might have forgotten. Understand? So with this, you can say, oh, cosine of 60, even though 30 was given in the paper. Even though 30 was given in the paper. But with your picture, you change it to 60 here. You can use the 32. I'll tell you in a bit. So whatever this is, NB. Please, your information should be detailed. This is not the way you should present it. So I will expect you to write in a statement form. Oh, from here, the normal vector of the plane is, you write it out. You call it your symbol N. Okay? From here, the vector direction or directional vector of the line is, you do that. Okay? Oh, from here, you write this formula. Then you can decide to write, evaluate that first. You can evaluate them differently, or you can put everything together. But at least describe what you are doing. Teach us through this process. Pretend I'm a dummy. You are trying to explain. Understand? So you have cos 60. Oh, sorry. Cos 60 is equal to, come here, the dot product of 2, 1, 2. So like I said, don't forget, from 2x plus y plus 2z equals to 3, the normal to the plane, okay, is 2, 1, 2, something like that. So that is what I need here, 2, 1, 2, and this one. That will be 2 times 1, 1 minus 2, right? 2 times p, absolute value. Because we're talking about acute angle. If it is not negative, if it is negative, you are going to, because this 2 will be positive. So you need to make sure this is positive. Otherwise, you don't have acute. You will be having something like this if you are not careful. You'll be having that. That's not what we want. Acute angle. Okay? You see, it says acute angle. Acute angle between the line and the plane. This is the line and this is the plane. So if this is acute, this must be acute. Understand? So this will be absolute value of the n. N is this one. So that will be square root. Absolute value is just square root, 1 squared. Like that. Then absolute value of the other one, which is this, 1 squared minus 2 squared and p squared. Cos 60 is sine 30, 1 over 2. This is paper 2, so which means you have your calculator. 2 minus 2, 0, so you are left with 2p. Again, absolute value, because p is in r, doesn't mean p cannot be negative. So you put your absolute value here. We're going to end up squaring both sides anyway, so the absolute value will be gone. And here, this will be square root of 5. No, square root of 9. And the square root of 5 plus p squared. Square square root of 9 will be 3. And then you square both sides. If you square both sides and you will solve, you get your results. And that would be the two possible values of P. When we did it in class, we wrote this formula in two ways. We call this alpha. So we agreed that sine alpha is cos theta is equal to this. Because if cos theta is this divided by this, it might be safe to say that, okay, this is cos, right? Adjacent over hypotenuse, something like that. In that case, you can use the sine. 30 and 60 are complementary angles. So sine of one must be the cos of the other. That's why we had two formulas that time. But only one is in your book. So the formula, the essence of writing this in two ways is that if you don't want to use this formula in your formula booklet directly, which is talking about the angle, finding the angle between a line and the between two vectors. This is angle between two vectors now. It doesn't take into account the angle directly between a plane and a line. Mind you, this is also a vector parallel to that plane. So it's not talking about, when you have it on the plane directly, it's not relating it to the plane directly. But it's talking about any two vectors. That is why we had to use this to get this so that we can work it out here. Okay? So please, you need to try to remember all this. The same standard of paper I want to give you next week. I think Monday will be a best time. I don't know. We'll talk about it. Because I want you to have a full paper like this, the same standard, but not more than a double period lesson. And if I'm going to maybe have a Tuesday and a Thursday, I will give you maybe half of the paper. I won't give you the other part. When you come on the next day, I can give you what you had on Tuesday and the next one, so you complete it. Then we can mark it again and see how you have improved with this feedback. And I want us to do that, maybe 1 or 2 times before your main exam, because I'm not so happy with what I'm saying so far. So, does this make sense? And that's how you get your P. Now let's see what the mark scheme wants us to show. Recognizing the angle between normal and the line is 60. That's reasoning. The angle between normal and the line. You see, it never talked about the 30 that was given in the paper. So if you have drawn this shape and you have shown this, we can see it. So we understand your reasoning. But you can just write a sentence to describe it. You look like you didn't sleep overnight. How many hours of sleep did you have?
6.
That's why. You don't look like crystal. This is like 60% crystal. Anyway, attempt to use the formula for the scalar product. Maybe by just stating something like this so we know. That's fine. Okay? You see, none of this has to do with your calculation. It's just the fact that you are presenting your idea. So you see, it's not just, you calculate, you get the answer. Present your idea too. 1, 1, 1 is something. Then it follows by all this. You substitute, you get the value of P, total 7 points. Possible values of P, which means when you find your square root also, you need to be mindful. And he never said, you see, it's all just in exact form. Was that a specific instruction? Just the possible values of P. Leave it in terms of square root. No decimal every time. And if you must leave something in decimal, there is an instruction at the cover of that paper. Can everybody please look at that cover? I don't know which line. Yeah, this number 3 from the last. What does it say? Unless, can you read that loud? Unless otherwise stated, all, yes, numerical answers should be given in exact. One of them is what you are seeing right now, in exact. Or correct to 3 significant figures. Why bother when you can just leave it in short form and get on with your life? Why bother press a calculator? And I noticed when I marked your work, especially in paper 2, a lot of you ignored that instruction. I overlooked it because it's internal mock, and I don't want, to give you a lower performance than we are already battling with. But when I'm giving you a review, a test next week, I will be so strict, and I'll tell you why. Look at this mark scheme. Accuracy of answers. If the level of accuracy is specified in the question, a mark will be linked to the given answer, to the required accuracy. So maybe the answer say correct to 2 decimal places. So there's 1 mark that will be linked to that. There are 2 types of accuracy errors, and the final mark should not be awarded if these errors occur. First error, rounding error. This applies to final answer, not to intermediate steps. Final answer, you didn't round appropriately. It's an error, but the last A1 will not be given. The other one, level of accuracy. When this is not specified in the question, the general rule applies to the final answer. And that general rule is already stated clearly, unless otherwise stated. Just like you have read, you must leave your answer in 3 significant figures. Do you understand? So please, this is very important, especially your final. So don't just rush. Just write. Want this nearest odd number? No. Get used to this thing. We have just a few weeks, guys. I think I'll close paper 2 so I can easily move around. Okay. So that's that about this. Now let's talk about this one. This question is very interesting. Please pay attention again. The question says, this function given in this graph as follows. Okay? And 2 questions, easy questions actually. Find the largest value of A such that F has an inverse. And this is where it is tricky. I understand why some of you might be confused. But your confusion, as far as I'm concerned, is based on the fact that you haven't done so much practice that maybe you are probably looking for every question should be similar to what you have heard. One of the objectives of IB is to bring that thinking skill out of you. Think about keywords in this question. Inverse. Greatest, isn't it? Say something like that, greatest value, right? Largest value. But inverse function. It must have inverse. And the inverse is definitely going to be a function. What do you know about inverse with respect to a function? Reflection. So if my function looks like this music instrument, then my reflection, let's just write a parabola. Let's just have a parabola, for example. Of course, the inverse will not be a function unless there's a restricted domain. Let's have a parabola, for example. The reflection should go this way, so I'm having something like this. Do you agree? If I have my vertical line test, do you remember vertical line test? If I slide it, when does it fail? When? Speak louder. when there are 2 points of intersection. So my vertical line test will fail after this point. Anytime you get in here, it fails. So if there is any part of this curve, maybe that goes this way, and can be seen on the other side, I don't know, maybe it comes this way, who knows? So maybe this can go the other way. It means, yes, it is invertible up to this point, and the moment it crosses this point, it is not invertible. So if my vertical line will, fail here, it means we can discuss my horizontal line being the test here. You see, it extends, right? So maybe the extension comes down. So my horizontal line will pass from here to here, to here, to here, to here, up to here. Then the moment it goes beyond this point, the horizontal line test will fail. So there are different values until you get to this point. So you can only find the largest domain at that minimum point. That is the reason you find the minimum point of this curve. Especially as you can see here. Am I making sense? So when the question is asking you, find the largest domain such that it has an inverse. It can only have an inverse if by the time we flip it to the other side, it will also pass the vertical line test. And where the point, you see there will be other point here, right? Largest value of A, sorry. Remember from the beginning, it tells us something about A. It says X is less than or equal to A. So we need to see the biggest one. So there will be so many X values until you get here. So X at this point, okay, X at this point is what we are interested in. Sorry, at this point. Does that make sense? Because X at this point is what we are interested in. So you find, you differentiate and we do the rest. Because we are talking about the minimum point. All you just have to do is explain. So if we differentiate, because of our time, maybe I just go through with the paper here. You see, you differentiate, you equate to 0, and you get your length 3. No decimals, please. Because it's not going to be exact, right? No decimal. The original function, remember, is this. You have to then remember how to differentiate the exponential. I hope everybody still remembers that. F prime of x. Brandy, be careful. I saw this in one of your papers. That's F inverse. Okay? I'm not sure I penalized you. If I did not, it means you're lucky. Because normally I'm not that nice. Just kidding. Okay. Exponential 2x times 2, right? Mm-hmm. Then 6 exponential x, 0. So if this is equated to 0, you factorize. And you can divide with a reason. Somebody presented the solution that way and say, oh, since this cannot be equal to 0, I love that. So 2 exponential x, for example, then exponential x minus 3. Remember, this is exponential 2x. That's why you can factorize exponential x out. It's equal to 0. So this person say, oh, exponential x minus 3 will be equal to 0 since 2 exponential x cannot be 0. So as a result, he or she divided both sides by that. Can only divide something you are very sure is not 0. Negative, positive, we don't care. Understand? And from here, exponential x is equal to 3, which means x is equal to length 3. Okay? So that value of x at that point must be length 3. There will be other x's coming here. The biggest one is the value of x at this point. That's why you have that. And the other part is to find the inverse. You see, the inverse here requires something elementary that you have done. You will notice this is the idea of completing the square. Why did they do that? Because this is not your regular algebraic function that you just, interchange stuff and the likes. No, it's not your regular algebraic function. Your y equals exponential 2x, 6 exponential x plus 5. You have to first put it in this form. Because how else can you make this the subject? If you look at it, even if you let your exponential x be maybe a, or let's say p, this will have been y is equal to p squared minus 6p plus 5. That is quadratic. So unless you want to use the, what's it called? Formula method. But if you use the formula method to evaluate p in terms of y, remember it will be p squared minus 6p, 5 minus y, 0. Even if you want to think about that. It means my p minus b will be plus 6, right? Plus or minus root b squared will be 36. Minus 4ac will be 4, 5 minus y. Everything all over 2a, which is just 2. But your p is exponential x. Can you see that? Which means my x will end up being the natural log of this, which is too complicated. That is why, even though it's quadratic, and you think, oh, this fails, if you're in the exam, you're experimenting different approach, go to your computing the square. And that's easy. Let's show how they got this. From your y equals exponential 2x minus 6 exponential x plus 5. I hope this is the correct function.
Yeah.
How do we do completing the square? You had something that will make it a square and remove it immediately, right? So you have exponential 2x, which is more or less exponential x all squared, 6 exponential x, then you are going to add minus 3 squared and remove minus 3 squared immediately. Is that not? And this 3 gives us what you want. Exponential x minus 3, this remains 9 plus 5, and that's 14. Wait, oh, there's a minus here. And that's how you got this level, this one. The reason for that is, if this is a square and this is y, when you try to isolate x, it's easy. X is now in one location. Understand? So now you have y, minus 4 becomes plus 4, and this is just exponential x minus 3 all squared, which you can now find the square root. So exponential x minus 3 is now plus or minus the square root of y plus 4. Okay? So exponential x is equal to 3 plus or minus square root of y plus 4. There are two values. One of them will have to be discarded. Is that not? So, but let's see. So x will now be natural log of 3 plus or minus the square root of y plus 4. So which means our inverse function, okay, I think we can, before we do the inverse function, oh yeah, maybe we should. Right. F inverse of x is equal to natural log 3 plus or minus square root of x plus 4, right? But we know something in the question. Your x is less than or equal to a, and your a is length 3. Is that not? Okay, so let's see. What is your length 3? Can somebody check an estimated value, what that is? What's your length 3? So 1.09, so basically we can say maybe less than 2. Right? X is less than 2. So if x is less than 2, 1 point something, Look at this. So we are having two options here. It's that we have lane